Everyone. Today we'll be talking about the concrete column US design template, and we'll go ahead and open it up here. It's listed under US columns in concrete rectangular column. When we open the calculator, so first thing we'll see is we'll notice that this calculator references ACI 31814, and the assumptions for this calculator are listed here. In the key properties here, we note you can enter your geometry properties, so such as the section height of the column and the section width. And we can see the cross section in this diagram here. The length of your column can be listed under total length. And one thing to note here is in the end restraint conditions considers what type of connections are at the end and changes the effective length factor. The column curvature type changes the magnification factor for end moments. So depending on whether it's single or double curvature, the magnification factor will change. And from there, once we see we've inputted our concrete geometry, we can go into inputting our rebar geometry. So this is the current configuration of rebar. We currently have 4 number 9 bars at the top and 4 number 9 bars at the bottom. In order to add rebars on the left and right hand side, we can go to additional left-right reinforcement bars and say we add 2 here. Then we can have a total of 12 bars along the perimeter of this column. And then we can set our concrete cover to ties here. So depending on where this column is located, if it's exterior and exposed to potentially chloride or high humidity, you might want to set a higher concrete cover. But by default, 1.5 inches is sufficient. And then here we have the minimum tie size and the maximum tie spacing. So ties are what confines our rebars to ensure that they don't splay out in compression. And in this case, this tells us that we need at a minimum number 3 bars at 16 inches for ties. And once we've set the rebar geometry, we can go in and see the loads. So the loads are all your typical column loads between there's actual loads and moment loads applied. You can also apply a moment via eccentricity. So you can have a default x-axis eccentricity and a default y-axis eccentricity. One thing to note is that even if you don't have y-axis loads, if you have a y-axis eccentricity and an actual load, we will apply this load with the default eccentricity. So in this scenario, even though there's no y-axis loads, we'll still see that we do check for y-axis actual interaction as well as moment capacity. And then here you can choose to include self-weight or not, as well as whether or not to use the reduced companion live load. And then the design code criteria we're using for this is the IBC 2018. The member properties are listed under member properties and can all be found here. For load combinations, we use SCE 716, and all the load combinations are listed here for investigation. And then one other thing of interest to note is that the method we use to find the neutral axis for string compatibility is the secant root finding method, and it's listed here. So finding the neutral axis along the x-axis, and we'll use the secant method and iterate through multiple iterations until it converges. Similarly for y, it's here. And then once all of the inputs are in, we can go up to see the summary, and we can see what the ultimate actual applied load is, as well as the capacity and the utilization of the capacity. And of course, we always have the traffic light check to tell you if the sheet is passing or not. And we also tell you what the potential failure mode is, or what the governing mode of that percentage is for x-axis and y-axis. And in our case here, it's compression. And that's all for the US concrete rectangular column.